What's going on, everybody? Welcome back to my YouTube channel. Look at this nice and beautiful question on the board that we're going to be solving. And the question says, find all solutions of x for which x to the fourth is equal to negative 64. Well, whenever we have a question of this form, we use a very famous identity known as the Euler's identity. And what is the Euler's identity? If you're familiar with the Euler's identity, it is given by e to the I pi equal to negative 1. So we're going to be modifying the right-hand side of this equation such that it has negative 1. So let's go ahead and modify. So we have x to the fourth equal to negative 64 is same as 64 times negative 1. So you notice that the right hand side now has negative 1. And since e to the I pi is equal to negative 1, I'm going to be replacing this negative 1 with e to the I pi. So x to the fourth equal to 64 times e to the I pi. Now, notice that x is raised to a power of 4. And because of that, we are supposed to be having 4 roots, which is 4 solutions for x. But if we make use of the Euler's identity like this, we're going to be having just one solution or root for x, and we don't want that. So in order for us to have different or distinct solutions for x, we have to modify this Euler's identity. So our next step will be for us to modify the Euler's identity. So we have x to the fourth to be equal to 64 times. Now modifying the Euler's identity, we have e to the I pi plus 2k pi. So you notice that I added 2k pi. So adding 2k pi allows us to have distinct roots or solutions for x. Also know that adding 2k pi does not change the argument as long as k is an integer. And since we are supposed to be having 4 distinct roots of x, the values of these distinct roots can be gotten from each values of k ranging from 0, 1, 2, and 3. So our next step will be for us to take out the power of 4. And how do we do that? It is simply by taking the fourth root of both sides. So x to the fourth, well, fourth root is still the same as a power of 1 all over 4. Equal to, we do the same thing to 64. Taking the fourth root of 64, that is 64 to a power of 1 all over 4. Times, we're going to be taking the fourth root of this expression. So e to the I times pi plus 2k pi. Taking the fourth root means raising this to a power of 1 all over 4. And from indices, powers multiply. So 4 cancel out 4 here, leaving behind x to be equal to, now the fourth root of 64 is 2 root 2. And now applying indices to this expression, which is the power inside multiplies the power outside, we're going to be having e to the I times pi plus 2k pi all over 4. Our next step will be for us to separate the fraction. So we have x to be equal to 2 root 2 times e to the I. Now separating the fraction, we have pi over 4, so pi over 4 plus 2k pi over 4, so 2k pi over 4. And this can be simplified into 2 root 2 times e to the I times pi over 4 plus 2, 1, 2, 2. So k pi all over 2. So you can see how simple this is. Let's continue. Our next step will be for us to write this expression in terms of cosine and sine. So x will be equal to 2 root 2. Now writing this expression in terms of cosine and sine, it will be cos, what is inside of the bracket, which is pi over 4 plus k pi all over 2, plus I sine, what is inside of the bracket, pi over 4 plus k pi all over 2. And then we close the final bracket. So we can get our distinct solutions for x by plugging in different values of k. So we start with when k is equal to 0. So when k is equal to 0, what is x? So x will be equal to 2 root 2 times cos. Now if k is equal to 0, this will be gone, leaving just pi over 4. So this is pi over 4 plus I sine. The same thing happens here. This will just be pi over 4. Close bracket. So x will be equal to 2 root 2 into, now watch, cos pi over 4 is same as 1 all over root 2 plus, now sine pi over 4 is also the same thing, 1 all over root 2 multiplied by I'll be having I all over root 2. Now let's open up the bracket, and when we do that, we're going to be having 2 plus 2i, and this is one solution for x. Now to get the other solution for x, we say when k is equal to 1. So let's plug in k equal to 1 to this expression. So we have x to be equal to 2 root 2 times cos pi over 4 plus, if k is 1, 1 times pi, that is pi over 2 plus I sine, we're going to be having the same thing as we have in this bracket, pi over 4 plus pi over 2. Now let's close our final bracket. Now by simplifying, we have x to be equal to 2 root 2 times, now when I have this is pi over 4 plus pi over 2. Cos of this expression gives negative 1 all over root 2 plus, now the sine of this expression is 1 all over 2, and when multiplied by I, we have I all over root 2. That's it. And opening up the bracket, we're going to be having negative 2 plus 2i. Now to get the third solution for x, this is when k is equal to 2. So let's plug in k equal to 2 into this expression. So we have x to be equal to 2 root 2 times cos pi over 4 plus, remember, k is 2, so I'm going to be putting 2 pi all over 2 plus I sine, we have pi over 4 plus 2 pi all over 2, and we'll close our final bracket. So x will be equal to 2 root 2 times, now cos of this expression gives negative 1 all over root 2, and sine of this expression gives the same thing, negative 1 all over root 2 times I. I'm going to be having negative I all over root 2. And now opening up the brackets, we have our third solution for x as negative 2, negative 2i. So now let's go for the last solution of x, that is when x is equal to 3. So finding a last solution for x, this is when k is equal to 3. So let's put that into this expression. So we have x equal to 2 root 2 times cos pi over 4 plus, now k is 3, so that's 3 pi over 2 plus I sine pi over 4 plus 3 pi all over 2. That's it. So this becomes x equal to 2 root 2. This first expression gives a value of 1 all over root 2. But this second expression gives a value of negative 1 all over root 2. And when you multiply that by I, you get negative I all over root 2. Now let's expand the bracket. This will give 2 minus 2i. And there you have it. Well, feel free to share your ideas in the comment section below. And if you enjoyed this video and have learned something from this video, go ahead and give this video a thumbs up. Subscribe if you haven't. Turn on the notification bell so you don't miss my upcoming videos. And like I always say, until next time, take care.